11th graders. So we are moving on with our second half of our first notes of this new unit. And so we talked about last time about all the different ways that we can see different relations. And now we're going to focus on really the big important part about this lesson, which is what makes something specifically a function instead of a relation. Now, anything that you can graph on a graph, anything that you can create a relationship between is a relation. But there's certain perks, I guess, of being a function. And we can talk about that. We will talk about that later. But what we want to focus on right now is how do we determine whether something is a relation or something is a function. So the definition of a function is that a function is a relation where every input, which remember that our input are our x values, like a machine, right? Our functions behave like a machine. And so we plug in something into this function, into this machine, and then it gives us something back. And so our input is typically the x value, has 1. So our input has 1 and only 1 output, which are our y values. So what that means is that every x value, if you think about it on a graph, right, here's our x-axis, every x value should only map to one y value, whether it's here or whether it's here, it doesn't matter, but as long as on that x value, there's only one output for that. You can think of it as like if you showed up to class, or if you showed up to your first day of school, and you went to a teacher and you said, I want to know what classroom I'm in for math. Where's my math classroom? There should be only one answer, right? There should be, you are going to this classroom. So that's you as an input and your classroom as an output. But if somebody was like, oh, your classroom is in this and this, in 302 and 409, you would be like, I'm still in a place where I don't understand where my classroom is because there's 2 different places that I should go. So which one should I go to? And that's the idea of the difference between a relation and a function. A function should funnel you to one number. Always. There's this like idea that it puts you to one spot. Now, it's okay if that same spot shows up, right? So like there's going to be multiple other people that are coming into that classroom. You've got however many other peers, 12, 13, 15 other peers coming into that same classroom. So it's okay if a bunch of inputs have the same output, but you as an input should only have one output. That's the idea. That's what makes something a function as opposed to just a relation. Now we have all the different ways that we can see relations, and we're going to talk about each one of those and what that looks like on what makes it a function or what is a function and what is not a function in this specific type of way of seeing a relation. The first way is a table. So we could have x values, -2, -1, 0, 1, 2, and I'm going to give you these y values in response. That -2 goes to 4, -1 goes to 1, 0 goes to 1, 1 goes to 1, 2 goes to 4. And now think about it. If I am the input of -2, I should be given one place to go, and it's here. Do you see -2 going anywhere else? No. Now, are multiple places, multiple numbers going to 4? Yes, that's okay. So you can write down, it's okay to see the same y value. It's okay. In these tables, it's okay to see the same y value show up. And that is still a function. This is a quadratic, right? This is -2 squared is 4, -1 squared is 1, 0 squared, 1 squared, 2 squared, right? This is a function. And it's okay that those values show up more than once because you're having multiple people going to the same room. Whereas if we flipped it with your x and y values, if we did 4, 1, 0, 1, 4, -2, -1, 0, 1, 2, you're now seeing 4 repeated and going to different numbers. 4 goes to -2, but then wait a minute, 4 goes to 2? That's like you being told your math class is in these 2 different classrooms. And you're like, well, then which one is it? Which one do I go to? I can only go to one, right? So it's not okay to see the same x value specifically with new y values. Of course, there could be a situation where you see 4 again later on, but maybe I switched it to -2, right? If it was 4, -2, and then later 4, -2 again, that would be fine. It wouldn't be because of 1, -1, and 1, 1. But if you saw the same x value going to the same y value later on in your data representation, it's a repetition. It's not really concise. Why did we repeat that value? I don't know. But if you saw the same x value going to the same y value, then I guess that's fine. But it's not fine when you see the same x value going to a different y value. So this is how you could potentially think about it when you're trying to determine whether something is a function or not when you are looking at a table. Okay, let's talk about a graph. Let's graph what this would look like. Your parent function for quadratic, which is what that table of values is, looks something like that. And that is what a function looks like on a graph. You can even have functions that look like this. All of those are functions, and how we know that it is a function is that it passes what we call the vertical line test. The vertical line test is like if you took your pencil and you scanned your pencil across this graph and you look at, will the line of this edge of my pencil ever hit my graph more than once at one time, right? Is this pencil hitting this graph more than once? It is not. As you can see, like the graph disappearing behind there, it's only disappearing at one point, right? We're focusing on just this one point hitting the line. Same with your parabola, right? That's totally fine. Your vertical line test is that, hey, it only crosses your graph at one point. Whereas this is what we call the inverse of a parabola, and it looks something like this. And this is not a function because it does not pass the vertical line test. You can see that as we draw in what would be this imaginary pencil, and it could be anywhere across the graph. Notice that it only touches there, right there at that vertex, once. But if you scroll over here, then it crosses twice. So it's hitting your vertical line more than once somewhere on your graph. A circle. You can absolutely graph a circle. There is a relation and an equation that is a circle. But the equation of a circle is not a function because it does not pass your vertical line test. So you can still create equations that are relations. They exist, they work, but they're not necessarily functions.